Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing recursion. So following the very first pattern, in the previous video we discussed what is linear recursion, what are different types of recursion as per the number of calls and based on how it is built. So today we'll solve the next question from the similar pattern, which is power of n on x. So let's read the problem statement. Here as you can see, we have to return the value of n power x, where if you see the constraint, it says x can also be negative and n, which is basically the power, can also be negative. Okay. Very first thing, if you remember, 2 power 1 was always 2, but when we have to calculate 2 power minus 1, if you remember, it was 1 divided by 2. Means when the power is negative, whatever at the numerator, it comes to the denominator, right? And when we have to give the final answer, we will divide 1 by 2 and it will become 0.5, and this is the expected answer. So remember, as the power can be negative, so we have to handle this very carefully. So now let's try to understand with this example. If x is 2.000, because it's given in double, so when we will add the power of n to it, then 2 power 2 is 4. Similarly, 2 power 3 is 8 and so on, and 2 power 10 is 1024. But as the value x is in double format, so we have to return in the double format. Okay, so our answer will also be in double format, correct? So that we can take care by taking a variable instead of integer, we can take it double. Okay, now in example number 2, if you can see, we have to take the power of 2 on 2 but with minus. So because this is minus, so whatever is the base, which is 2, it will come to the denominator. Can I say that? Yes. And now the base will not be 2 anymore, it will be 0.5. Can I say? And we have to give the power of 0.5 and power will become positive, which is 2. Can I say this? Means, can I say one thing? Ki if my n is negative, means if my power is negative, I want to do two things. First, I want my x to be 1 by x, because 2 needs to be 1 by 2, correct? And the power is in negative, right? So I want to make it positive. Why? Because once, like, negative sign is only to make this numerator into denominator, correct? And then once it becomes 0.5 from 2, now we can, now we want to calculate the same positive power onto it. So 0.5 multiplied by 0.5, it will become 0.25, and that's what the expected answer in example number 3, correct? Okay, now when your power is negative, you are changing the numerator into denominator. First, so you are doing the conversion of the base, and second thing, you are making the power positive. And if you see the constraint, it says minus 2 power 31, like the power can go till negative, and if you know, this is the minimum integer value possible, correct? So when you will convert this into positive, it will become 2 power 31 in positive, and if you know, in positive, 2 power 31 minus 1 is the only limit an integer can hold. Means 2 power 31 will go out of range for integer. Hence, we have to save this power into double format only for this extra edge case. Okay. So if I am clear, definitely we can write the code in the iterative approach, correct? Once we write the code in the iterative, definitely we will convert this into recursive one. And if you can see that, it will become the linear recursion. How? Let's see. What was the very first thing? If n, which is the power, is negative, what I want to convert this x into 1 by x, correct? And I want to convert, change my power into positive back. Once it is done, okay? But in example number 1, it is not negative, so there will be no such changes for that. So let's calculate the answer. If we have x is equal to 2 and n is equal to 10, there are two ways to calculate our answer. The very first approach is keep on multiplying this 2 for 10 times. Can I do that? Yes. Keep on multiplying for 10 times, okay? But in that case, the time complexity will be, because we are multiplying this for 10 times, the time complexity will be O of n, correct? This is a brute force code. Can we optimize it further? Why? Because we see a similar pattern here. means if we are multiplying this for like 10 times, so I know one thing, which is if I can get 5 times, see 10 times means nothing but, can I say this, if I can get the answer means 2 power 5, I will multiply that 2 power 5 2 times to get our final answer. Yes, I can say that. Okay, so what I am saying, let me briefly explain to you. See, 2 power 10 I want, 2 power 10. So I am saying if I can calculate 2 power 5 somehow, I will double it. Let's say this is a, so I will double it. I will multiply this with another a because 2 power 5 I have. So I will multiply this for 2 times. So I can get final answer 2 power 10. Correct? So basically, don't you think if suppose O of 5 time complexity you somehow taken to calculate 2 power 5, and now I will simply multiply this with the same answer which we have calculated, then we have actually saved our extra 2 power 5 calculation which we would have done, but now we don't want to do that. Why? Because left half we already have, we will double it. Correct? Now with the similar theory, 2 power 5 said ki if I can get 2 power 2, I will double it to make 2 power 4. Now because the power was odd, you can see 5, so we will multiply with 1 extra 2. Okay, that we can mention the logic. Let's see. Now again 2 power 2 said ki if you can give me this 2 power 1, okay, then I will double it and I will get the answer. Okay. Now let's break for one more time. 2 power 1 said ki if I can break this into 2 power what, then I will double it to make my answer. Okay, and once your power becomes 0, stop, because no matter what the base is, if the power is 0, the answer is 1. Correct? So this answer 1 we can return to this. So this will become 2 because we are multiplying. So 2 power 1, 2 multiplied by 2, so we will get 4. Now this 4, like the leftmost 4 we have got, for rightmost 4 now we are not going to calculate the similar way we have calculated. No, we'll just double it. Okay, so it will become 4 multiplied by 4, which is 16. Correct? So 16, because it was odd, so we'll multiply with one more time 2. That will write in the logic. If my power is like odd, then just simply multiply by 1 extra x, which is 2 here. Correct? Okay, now we have got 16 multiplied by 2, 32. So I can say ki hey, for 2 power 5 I have got 32. Means whatever time complexity I took to complete or to calculate this left half 2 power 5, for the right half I am not going to do the same thing, or I am not going to repeat it. I will simply multiply this with 32 into 32, which will take O of 1 time complexity. Correct? So when you multiply this, you will be able to get the answer, which is 1024. Okay, so instead of iteratively doing for 10 times, which was n times, see how many calculations you did here, which is 1, 2, 3, 4, just 4 iterations. Okay, why 4? Because if you will calculate, we wanted 2 power 10, right? So you know we want to reach there by half of times. So 2 power how much we can reach to 10? 2 power how much? So can I say 2, 2s are 4, 2s are 8 and 2s are 16, it's 3 point something, that is why it was 4. Okay, the number of iterations it took is 4. Correct? Now if it was, suppose instead of this it was 100, let's suppose, or let's suppose instead of this it was 64. So if you would have done using the iterative for loop, then you will be taking 64 time complexity. But if you will do this way, because you are actually at every step you are ignoring the rest half and you are focusing on the left half. Correct? Because for the right half, if you will get the left half answer, you just double it. Can I say that? Yes. So hence you have reduced the time complexity from O of n to logarithmic of n base 2. Why base 2? Because you are dividing into 2 halves. If you are dividing into 3 different parts, then logarithmic of n base 3. Remember that. So let's write the code for this. First of all, we want to convert this n, let's name it exp, into n. Why? Because if somehow our exp, which is exponential power, is negative, then our task is to convert our x into 1 by x, first thing, and second thing we have to convert into negative. Correct? So if if our exponential, which is n, is 2 power 31 minus 2 power 31, then definitely making it positive will go out of index. Now we'll initialize our answer variable with double because we will store our answer here. Now we'll run until our exponential is greater than 0. Inside this, what is our task? If you remember, if our n was odd at any point, okay, is not equal to 0. So if our n was odd, what we did in our answer, we simply multiplied with extra x there, correct? Or else we just doubled our x outside, yes. And also we have to divide, like make the exponential power half. So we will divide the exponential, correct, by half. Done. And after coming outside, we can simply return our answer. Let's see how it works. Now let's run the code. As you can see, it's running, so let's try to submit this. As you can see, it's fastest because the time complexity is not O of n now, it is logarithmic of n, because at every step we are ignoring the rest half. How? Let's see the dry run for this. Initially the exponent exp will be 10. Let's take the example number 1, correct? So when exp is 10, definitely it is not odd, correct? And here will come, x will become what? We are doubling the x. What is x? 2. So 2 multiplied by 2, it will become 4 point something, let's say 4, okay? Now exponential power will become half, so it will become 5. Can I say? Yes. Next time exp, which is 5, is odd, so we'll come here and the answer will get multiplied with x. What is x now? X is 4, so answer will become 4. Again we'll come here, we'll double the power. Now 4 multiplied by 4, it will become 16, and this power, which is exponential, it will become half. So again 5 divided by 2, which will become 2, correct? Here we'll go. Now this time 2 is not odd, correct? So we'll not multiply anything in the answer, but the power will get doubled, and 16 multiplied by 16, it is 256. Now here power will get half, 2 divided by 2, it is 1. Next time we will go here, and 1 is definitely odd, so answer, which was previously 4, it will get multiplied with 256, and when we will multiply this, it will become 1024, okay? Now here what is x is 256. This 256 will get multiplied, let's say some value xxx. Here the exponential power, which is 1, when it will get half, it will become 0.5, means 0. Next time we'll check in the while loop, is it positive? No, it is 0. So we'll come out of the loop, and whatever the answer was stored, which is 1024 point something, it will get returned. So if you see the number of iterations, we have not performed 10 times. Here we have just performed 4 times. And that is why the time complexity is logarithmic of n. So I hope you understood, but still this was definitely logarithmic solution, but we have written this in simple while loop, correct? Can we convert this into recursion format? So let's write the code. Whatever we did there in the while code for the negative case, the similar we have to repeat here also. So we'll convert this exp into long first, and then we will check if our exp is negative. Then there are 2 things to cover. First is, let's make x to 1 by x first, and second, let's convert this exp into negative of exponential. Done. After this, if you remember, in the while code we initialized our answer variable, but in this recursion we will try our recursive code to return this, okay? So we don't need to initialize that outside, but we will initialize in the same function call. So we'll make a function, and that function call we will return here. So let's name it power. So in that we need to send definitely x and exp, if you remember, and one more thing, which is answer. So we have to initialize this, correct? Done. After that we have to make a function, which is power, but the return type will be double. That's what expected from the function. So we'll make a function called power, and there we have to take, so what is the type of x is double, so we will make double and x. Now what is the type of exponential? It's long, so we will make long of exponential, let's name it n, and return the answer type will be double, so let's name it double. Done. Now we have to add the base case. So in the while loop, when we wanted the while loop to stop, definitely when n hits 0. So here in the base case we have to write if n is equal to 0, return. But what needs to be returned? See, there are 2 types of recursion we have learned: functional and parameterized, and this one is parameterized recursion. Why? Because this answer which we are looking to calculate, this I have mentioned in the parameter. So if you remember, in the parameterized recursion, Once we hit the end case or the topmost case for the recursion, then at the end we have calculated our answer, correct? So when we hit the base case, our answer is ready. So instead of simply returning, we'll return our answer here. Okay, if you're still confused why we did, then definitely your recursion part is not clear. Means what is functional, how and where we calculate the answer in functional recursion and where we calculate the answer in the parameterized recursion. So I will recommend you to watch that video, and then definitely this will make sense. Once we are done with this base case, now our condition was to check what if n is odd. So if n is odd means we have to multiply our answer with an extra x factor. Done? Or else what we did, we doubled the base, which is x, and we halfen the power, and that we will not do manually here because we are calling a function which is recursive call. So we will do everything in the function, okay, with the parameters. So we will return and we will call the same function which is power. And now what we have to do with x? Double, so we will double it. What we have to do with power n? Half, so let's half it here. And what we have to do with answer? Nothing, because answer though we have changed here only, right? Yes. So now at the end this will return to this and the final answer will get returned from here, correct? So everything are same. Let's try to run the code, and yes, it's passing. So let's try to submit this. So as you can see, it also has been passed with the similar accuracy. The reason is, even if it is, you know, recursive code, but the time complexity is same logarithmic of n. Okay, so in recursion, as it is linear recursion instead of non-linear, so the time complexity will also be linear and not 2 power n. But here, as we are going with the half part at every iteration and ignoring the rest half calculation, so that is why the time complexity here is logarithmic of n. It's not linear exactly, but it is logarithmic of n. Why I have categorized in the linear one? Because if I will make multiple patterns of it, then it will be very messy. So the only reason to divide this into 2 patterns was this, कि not every time the recursion means 2 power n solution. It can be linear, it can be logarithmic. So if you understood this, then definitely here is the Python code for you if you are from Python background, and here is your C++ code if you are from C++ background. So if you understood this, definitely you are eligible to go in the sheet and mark the last question of this pattern. Again, expecting you all would have done this on your own because this is very easy. So I am closing this linear recursion pattern, and in the next video we'll cover the next pattern. Hoping you all have this sheet with you. If not, then definitely I'll add the link in the DMs. And if you like the explanation and if you understood each and every concept here, I will definitely expect a like and a comment on this video, because that gives me more motivation to make more such videos for you all. And that's it guys, with the hope that you all are following my pattern wise playlist. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family too.